So for this problem here, we have a parabola that's upside down, and that's the equation of the parabola. And there is a cylinder that is sort of inscribed within the parabola. And there's a point here that's called X and Y. And I want to point something out here right away in green. I want to point out to you that this here is X and that this here is Y. And I also want to point this out. You see the cylinder, the pink cylinder inside, it has a radius that goes from here to here. Maybe I can use a highlighter, and let me use a, how about like a burgundy highlighter? You see that there? That is the radius. Can we agree that this is the radius of the cylinder? But I want you to see that this here is the same as that there. Let me try that again, here to here. So for this problem, it turns out that the radius is the same as the letter X because they represent the same length. So for this problem, what we have over here in the top right is that the radius is just X. Now here, can we agree that this pink cylinder, the height of the pink cylinder would be this here? Let's go with a yellow highlighter. Can we agree that the yellow highlighter is how tall the cylinder is? But that's actually nothing more than the Y coordinate of this point. So what I can do over here in blue is I can say that the Y coordinate is going to be just Y. But you see in the directions, that's not fair, because in the directions, they said that the radius and that the height, they have to be in terms of X. What that means is you can only use the letter X. So we're okay with the radius because the radius is X. But over here, instead of calling it Y, you know what we should call it instead of Y? Well, what does Y equal? Y equals 4 minus X squared. You see that? 4 minus X, that's what Y is. For this problem, Y equals 4 minus X squared, which is why I'm gonna call the radius is X and the height is 4 minus X squared. So what we can now do here in blue again is we have the volume formula given to us for free, but I want to write everything in terms of X. Right? So the volume is pi, R is X squared, and then H, the height was 4 minus X squared, which is right here. So let me actually just grab this here. Let me just move this to this side. Let me leave it right there. That looks a little better. And so now we have the surface area is 2 pi R, and then H is 4 minus X squared. And that would actually be plus, I ran out of space here, but plus 2 pi R squared, right? That would be the formula for the surface area when you plug in the R and H in terms of X. Now, to finish this video, we can find the maximum volume and the maximum surface area. So what you should do on Desmos, because in the directions they're like, hey, go to Desmos. On Desmos, we should type this in here on Desmos. The volume equals pi X squared 4 minus X squared. And let me see if I can stop the share, and we can go to Desmos. And if we graph it here on Desmos, and if we zoom in the first quadrant, right, there's the formula for volume, I get this here. So what I want you to see is that this number here is the X coordinate, and this number here is actually the volume. You see that? Because here, the input is X, and the output is volume. So the maximum volume is 4 pi, and the X coordinate is 1.414 and some change. So let's go back to our whiteboard, and let's go and let's tell them that the maximum volume was 4 pi, and that the radius is 1.414. Now, you know what? I've seen, you see this 1.414, that's actually a decimal that keeps going, but I actually recognize this number because I've been doing math like forever. This number here, this 1.4142, I actually recognize it as being the square root of 2. We can discuss later how I got that, but I just happen to know that this weird decimal is actually the square root of 2. But yeah, I mean, if they're okay if you leave it 1.4, I mean, it's totally fine. So they wanted to know the maximum volume, 4 pi, but they also wanted to know the radius and the height. Well, I know that the radius is 1.4142 because that's what x was. And remember that for this problem, x is the same as r. So how do I find the height? Well, I know what r is. And remember, r is x. So what I'm going to do is I'm going to take this number, 1.414 and change, and I'm going to plug it in here, right? Because again, remember that x is the same as r. And this is like 1.414 and change. So if you take this number for x and plug it in there on a calculator, it'd be like 4 minus 1.41 and change squared. And if you tap that into a calculator, you're going to get really, 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 really close to just the number 2. Or at least you should, right? It should be pretty close to 2. And so that's how you find the maximum volume and the radius and the height that goes with it. Now, to finish this problem, let's do the same thing, but this time we're going to do it for the surface area. And the equation we have there, so I think I typed it in for us right here. And let me zoom out and zoom in on the part that's important up there. You see this here, that's the actual maximum surface area. And this is the x coordinate or the radius that we need. So 1.535 has to be the radius or the x coordinate, and 30.658 is the actual maximum surface area. So I'm just going to round this to 30.7 and to 1.5. 30.7 and 1.5. Let's go back here. So we said about 30.7 and about 1.5 and some change. And what you would then do to find the height is, again, you would take, let me take up some of these themes here. You would take the 1.5 and you'd go 4 minus 1.5 squared. I actually happen to have a calculator here in front of me. And if we type all of that in, and again, this is just an approximation because I was just rounding like however I wanted. So I get about 1.75 for the height. But again, I would ask the teacher how they want you to round and just, to do as they say. And so that's how a problem like this can be done, where the x coordinate was the radius, the y coordinate was the height, and the y coordinate is just the equation. And that tells you what r and h were, x versus 4 minus x squared. Then you took these r's and h's, which were in terms of x, you plug them into your two formulas and you graph them on Desmos, and you just go from there. So hopefully that helped. And if you have any questions, just let me know.